Hello dear students, today we are going to discuss a very important topic and very interesting one. So this topic is electric motor. Topic name is electric motor. So where we see motors in fan, in pumping motor, water pumping motor, etc. Isn't it? Even your mixer grinder, and in many of these places we are seeing electric motors. What is the function of this motor? Electric motors convert electrical energy into mechanical energy, isn't it? They are converting, that is fan, it's converting the electrical energy into mechanical energy, that is it's giving a rotational effect, that is mechanical. Electrical energy is converted into mechanical energy. So generally we can define electric motor as a device which converts electrical energy into mechanical energy. There are two types of electric motors. They are DC motor and AC motor. DC and AC. Two types of electric motors. They are DC and AC. The working and functions of DC and AC are very much different from each other. Now we are going to discuss about DC motor. What is this DC and AC? We will discuss later. Okay, DC, the full form of DC is direct current, AC is alternating current. The current that we get from battery sources, that is DC, direct current. DC have positive and negative terminals. And AC current, they do not have positive and negative terminals. That is the current we obtain from our switchboard in your home. The AC current, the KCB is giving us AC current. And we are converting them into DC current through our inverters. If you have any inverter in your house, you may be using a battery as well as inverter if you are using inverter set. So actually this inverter is used to convert the DC into AC or AC into DC. So they are inverters. Now just understand what is DC. DC is the direct current and AC is alternating current. Alternating means it do not have a positive or negative for fixed time. Its negative and positive will be keep changing for a second, 50 times in a second or 100 times in a second. Okay, that we will discuss later. Don't be confused by that terms. Just understand that electric motors are of two types. They are AC and DC. And here we are going to discuss about direct current electric motor, that is DC electric motor. So just focus on DC only. DC is the direct current, the current we obtain from battery, that is DC source. Now let us go to the setup of this experiment. So for this one we need to have one magnet here. It shows the south pole here, and if we can use the same magnet, we can use a horseshoe magnet, that is U-shaped magnet, so that it will cover like this. So south pole will come here. So anyway we have to get one north end and one south end. Either we have to use two magnet or one magnet. Now if we use a magnet, obviously there will be a magnetic field. What will be the direction of magnetic field? From north to south. So just keep in mind the direction of magnetic field, north to south. And now after magnet we need a coil, that is a conductor. This conductor is called armature coil. And it is named ABCD. This armature coil is named ABCD. It is fixed in an axis like this. It's moving in an axis like our globe. Here I have a globe. For third class students I brought this. See here, it's moving in an axis, isn't it? As like this, our armature coil is fixed in an axis, so it can rotate in an axis. So that is the experimental setup. And now here we have two rings. These are called split rings or commutators. So we have the rings R1 and R2. Hope you can see this small writings R1 and R2. They are two split rings. Split rings means it's not complete ring but ring like this. They are splitted into two half rings. And here two brushes B1 and B2. They are two brushes. That brush is actually made up of conducting material. That is, the brush of conducting material means it is made up of some aluminum or copper or such like substance. So these brushes are made up of conducting material. Now it is connected into a battery source. This one you know, it's a battery. So once more, what are the things we used? We used a magnet with a powerful magnet with north and south pole pointing towards it, and an armature coil which is named ABCD, that is a conductor, and it is fixed in an axis, and from which it is connected to a ring R1, and on the other side it is connected to R2. From there it got two sliding contacts is by using brushes B1 and B2. So here we have armature coil, rings, brushes, and then it is connected to a battery source. This is the experimental setup. Now let's look what happens. So here current flows from the positive direction to the negative direction, isn't it? Current flows from positive to negative. So firstly, current starts moving from here. This is the positive terminal. The bigger one is the positive terminal and smaller one is the negative terminal. So current starts moving from this end, from the positive terminal, and it moves through here. It reaches in the brush B2, and current starts moving through here. It reaches in the ring R2. And from ring R2, here is a contact to the armature coil. The current starts flowing through here from C to B and B to A and A to D. Now, let's check. Either we can check here or here. For our convenience, let us check here. What happens when the current reaches here? I will explain how to check here the motion of the conductor. Now we are going to check the motion of the conductor when it reaches here. We know if a conductor is placed in a magnetic field, it experiences a force, and that force is explained by Fleming's left-hand rule, isn't it? Fleming's left-hand rule helps us to find the direction of force if a conductor is placed in an external magnetic field. Here the conductor is placed in an external magnetic field, therefore it experiences a force. Now let's check what is the direction of this force. Here, direction of current, this finger shows the direction of current, that is middle finger, isn't it? So I take it here, and this finger shows the field, forefinger shows the direction of magnetic field. It is from north to south. First of all, I told you to remind it. So here current is in the downward direction, magnetic field in this direction. What happens? The force of the conductor or the motion of the conductor will be in this direction, that is towards you or outwards of this board, outwards from this board, isn't it? So it experiences a force outwards. So slowly this AD starts to move and it experiences a force and it reaches here. What happens? AD starts moving from here and it rotates along the axis and it reaches here. Now these portions become AD. Here AD is moved to there and BC reaches here. AD from here reached here, isn't it? Now again the current moves through here and it reaches here, isn't it? Again now current flows from the positive terminal, it goes through here and through here from D to A. What happens when it moves from D to A? When it moves from D to A, we can apply Fleming's rule here also. If we are applying Fleming's rule here, what happens? The direction of current is here, but direction of magnetic field is again here, north to south, that is north to south. Direction of current here to the vertical direction, upward. Force experienced will be towards, that is inwards, the inwards of this board. So what happens? This AD will move inwards. This AD will move inwards. At the same time, the current reaches here. When it reaches here, we can apply again the Fleming's rule here. What happens? Current is flowing downwards. Magnetic field in this direction forces towards this direction. BC moves outwards. AD moves inwards and BC moves outwards. It becomes a speedy motion. As AD moves backwards or inwards, BC moves outwards, and again the next rotation happens. So now here our AD reaches back here, and BC reaches back into the same position. So it completed one rotation. Hope it is clear. First of all, the current flows through here and reaches at C, and when it reaches at C, we can apply Fleming's left hand rule. When it reaches at C, current in this direction, magnetic field towards north to south, force or motion of the coil or conductor will be inwards of this board, so it moves inwards. As the current reaches here, at the same time current will reach here without waiting. The current will reaches here, and when it reaches here, current is moving downwards, magnetic field towards the right side, and motion will be outwards. This will move, and it will continue to move with a very speedy motion, and hence we get a mechanical energy from electric energy, isn't it? Electric energy is now converted into mechanical energy with the help of one thing. What is that? When a current passing conductor is placed in a magnetic field, it experiences a force which brings a rotational effect on this. That is the principle of this electric motor. What is that? When a current carrying conductor is placed in a magnetic field, it experiences a force. This force makes it to rotate along or rotate in an axis. Now to the construction part, already discussed. For construction we need armature coil ABCD and two magnets or the two poles of the same magnet. Next one, we need two rings R1 and R2, a brushes B1 and B2, a battery also, a battery source. And working, when the current passes in the coil, that is from positive terminal to the negative terminal, when it is passing through C to B, when we apply Fleming's left hand rule, we got the direction of motion of this coil will be inwards of the board or inwards to the surface, and when the current reaches in the place AD, in the plane AD, the coil moves outwards of the surface, and hence it produces a rotational motion, and it will continue without stopping until we are giving a source here. Until the battery exhausts, this will continue its motion. And the same thing you can see in mini motors. In the toys you can see mini motor that is working on the basis of same principle. We are giving a battery source, and from that battery source it includes this magnet. Inside the mini motor there will be magnet, and there will be a coil like this, and it is rotating when we are giving the current into the two ends of the mini motor. So that is happening there also. So that is the principle and working construction of electric motor. Now this electric motors is used in toy cars or even in the motors, pumping motors, in some of the big machineries also that runs based on this electric motor. And the big use of this electric motor is to convert electrical energy into mechanical energy wherever we need it. For example, in case of fan, in the case of mixer grinder, and many of the cases we can see this electric motor. That is the uses of the DC motor. Hope this section is clear for you. It's a very important section. That's why I discussed this topic alone one day. So if you have any doubt in this section, you can contact me. And see, one more thing, you can get many animated videos of this electric motor to get a more clear 3D image. You can get a lot of animated videos of electric motors in YouTube. Either I will help you or you can search yourself also. If you are not getting, you can contact me for help. I'll help you to find animated videos, that is 3D videos of this electric motor. Thank you for watching. Have a nice day.